insertion features. So in this module, we're going to talk about how to exclude scan cells from scan chain and the differences in behavior. We're going to control how to put cells on a specific scan chain and the scan interface signals for the chain. We will discuss multiple modes of operation that define different scan architectures, as well as partitioning the design to define different scan architectures for each partition. First up, we're going to talk about final control of scan chains. In Fusion Compiler DFT, any valid scan compliant registers will be excluded from scan paths if you do one of the following. Either you specify syscan configuration -exclude elements to exclude the cell from being stitched, or you apply the scan element attribute by using the syscan element false command and set it to false. Note that any registers excluded from scan paths will appear as black boxes for combinational ATPG tools such as Testmax ATPG, in which case only sequential ATPG can generate tests for registers that are not included on scan paths. There's also a way to control unscanning of a register. Unscanning refers to returning a DFT violated scan flop into a non-scan flop. To do that, use the command set DFT insertion configuration -unscan option. The default is false, which means the tool will not revert a scan flop that has DRC violations into its non-scan version. To specify cells that to be excluded from the scan chain but remain as scan flop, you should use the syscan configuration -exclude option. If you do that, the cell will not be stitched to the scan chain, but it will remain as a scan flop. If you want to specify a register to revert back to its non-scan version, you can also use the syscan element false command. Next up, we'll talk about specifying scan groups. Scan group is a group of scan cells that should be grouped together during scan stitching. For scan groups, no other cells will be inserted between elements of the group. Now, Scan Architect may optionally order the cells within the group. Therefore, it is not a hard order when you specify a scan group. A scan group may include one or more of these instances: cells, design instance names, or core segments from test models. You can specify a scan group using the syscan group command. If you want to remove a previously specified scan group before running insert DFT command, use the remove scan group command. And to report on a previously specified scan group, use the report scan group command. Here's an example of specifying a scan group that has already been stitched. So use the command syscan group. The key is the -serial route true option. You then specify the name of the group, include the elements of the group, as well as the access pin to this group. A second example is a serial route false option, which is to say to the tool, these three registers exist in the design. You want to keep them together, but it can be grouped in any order. Also, SetScan Group can include a core level segment in this include option. Next up is to define a scan chain using the SetScan Path command. The SetScan Path command is a hard order telling the tool how to build the scan chains on a chain-by-chain basis. You can use the SetScan Path command to specify the name of a scan chain, if you so wish, which ports are to be used for a given chain, or which scan cells are to be used for a given chain. The SetScan Path command supports these options to control elements of the scan chain. Include elements, which means that the cells needs to be included in this path, but not necessarily in the order that you have specified. -ordered elements tells the tool that you wish to stitch these cells in the order that you have given. -head elements means that the tool will put these cells at the beginning of the scan chain. -tail elements gives the order that these cells should be stitched towards the end of the scan chain. -complete true and false indicates to the tool that you allow or disallow cells to be added to this particular scan path after specifying all these items. Note that the elements options only accept a tickle list and not a collection. So in this example, the -order elements will fix the order of the cells in the scan chain. Also, if you specify the -complete true, then the tool will not add additional registers to this particular chain. You can use the SetScan Path -scan master clock option to specify the clock driving these registers to be included into a path. And you can optionally specify whether it is the rising or falling edge of the clock to be included on that scan path. Next, we're going to talk about multiple test modes. So why do we need multiple test modes? Well, a design could have different scan architectures for different testing steps. For example, at wafer probe stage, you may have more test ports available to you rather than at package testing or even at burn-in. Some of the DFT features would need to be enabled or disabled independently from a regular scan mode. For example, if you have UCC in your design, or whether you're not using compression, sometimes you want to test the design without any use of compression. To accommodate all these different test requirements, you can define multiple scan architectures on the same scan design. And what this means is these test requirements need to be specified by defining multiple modes. So using multiple test modes, you would first enable the general multi-mode flow with this app option. After that, you need to define your test mode ports using the set DFT signal -type test mode option. And then use the define test mode command to declare all the user-defined test modes that you're going to use. The declared test modes can be decoded one hot or binary. The default is binary. Once you have specified the complete list of defined test mode commands, Fusion Compiler DFT will automatically insert the test mode decode logic. Let's talk about the command define test mode in a little bit more detail. So first you would use the name of the mode, the dash usage, which is to tell the tool what's the usage for that particular test mode. There are certain use cases such as scan or compression, or whether or not you're going to use wrappers for a particular test mode. You can explicitly provide the test mode encoding, or if you don't specify anything, just by defining a scan test mode, you can just use define test mode, the name of the test mode, and you're set. If you want to define a compression mode, you can specify the dash usage scan compression. Once you have defined these test modes, some of the Fusion Compiler DFT commands can then be made mode specific by specifying the dash test mode option in the command. So in this example, I can specify for a particular test mode to have a certain chain count. These are the commands that can be made mode specific: sescan configuration, sescan compression configuration for DFT max compression, sescan path, set DFT signal, and write test protocol. For the sescan configuration command, there are certain options that are mode specific, namely the chain count, max length, clock mixing, and exclude. In the preview DFT report, the command will print mode specific scan chain information for each of the test mode you have defined. Preview DFT will append bracket M next to the scan element to indicate where the reconfigurable multiplexers are inserted. Here's an example. So towards the end of Preview DFT report, you will see the test mode controller information as well as the test mode signals and how they're encoded. In the main report, the bracket M indicates that there's going to be a reconfigurable multiplexer inserted and being driven by a particular register. Let's look at an example of multi-mode multiplexers. In this design, we have inserted two test modes, one that has a single scan chain and one that has 3 scan chains. These are the location of the multi-mode reconfiguration multiplexers. When the test mode signal TM is asserted to 0, it will drive the scan data from each of these scan in and scan out ports. Whereas if test mode signal TM is set to 1, this configures the design into a single scan chain mode so that the scan data will traverse through each of these registers and the data will go from test SI1 to test SO1. A note about running design rule checking in multiple modes. Before scan is inserted in the pre-DFT DRC, the checks are not mode specific. So you cannot say a particular signal is asserted in a particular test mode prior to DFT insertion. In post-DFT DRC, the checks are not run against all test modes simultaneously. You have to run post-DFT DRC checks test mode by test mode by specifying the dash test mode option to the DFT DRC command. Writing out the multiple test mode test protocols. The test protocol information for each of the test protocol file is unique to each of the test modes. You will need to write a separate test protocol file for each test mode to pass on to testmax ATPG. using the write test protocol-test mode option. In this example script, I'm defining 3 different test modes. Prior to that, I first specify general multi-mode support. I specify a mode decoding style binary, since I have not explicitly defined the encoding of each of the test modes. I then specify the test mode ports that are used to configure the design into each of these test modes. I then define the names of the test modes and the usages. At the last define test mode command, I need to use the reset test mode command to reset everything. Then I will specify the command setscan configuration and give the mode-specific chain count, like this. When you have inserted multiple test modes to a design, each mode may require a separate custom initialization sequence to establish the mode. Perhaps you have some sequential controller that will be controlled by its own top-level port control signals. You can use the read test protocol command to specify the test setup initialization procedure for each of the test modes. With this command, this allows the user to check post-DFT-DRC for multiple modes within Fusion Compiler. So here's an example script with post-DFT custom initialization. After insert DFT, I can read the setup procedure for each of my scan modes and then perform DFT-DRC. At the end of this, I can write out the test protocol which incorporates the custom test setup sequences. Next, we'll talk about DFT partitions. Let's talk about DFT partitions. In some cases, you might want to apply different DFT configurations to different parts of the design. This is particularly true if the synthesis flow is bottom-up, but the DFT flow is top-down. To define the DFT partition, use the define DFT partition command, give it a partition name, and -include to include a list of cells for that partition. If a design name is used in the -include option, all the instances of that design will be included in that partition. A particular design or instance can be specified in only one partition, so you cannot put the same instance into multiple partitions. A reserved partition called default partition will include sequential logic not defined in any user-defined partition. So you cannot use the word default partition as the partition name. Once you have defined a partition, you can then specify the scan architecture for that specific partition. To apply the commands to that partition, you need to first set the current partition using the current DFT partition command. This will set the current partition to a specified partition name, and then all the subsequent scan or DFT max specifications will apply to only that partition. The current DFT partition command must specify a partition that has been previously defined. Note that not all commands or options of a command can be made specific to a given partition. So if you have commands or options that cannot be made per partition specific, they are ignored with no warnings. So let's look at a script example. You would first define any global DFT configurations prior to any defined DFT partition commands. So in this example, I have defined partition P1 to include blocks block 1 and block 2, and another partition P2 which includes block 3. I can then specify for partition P1 to use a specific scan enable port, scan data in and scan data out, as well as the scan configuration chain count. For partition P2, I may have a different scan enable signal, a different sets of scan in and scan outs, as well as a chain count. The preview of DFT report will give information about partitions. It will append the name partition as part of the scan chain report. So in this example, I have chain 1s and 2 come under default partition. Chains 5 will come under partition P1, and chain 6 come under partition P2. Lastly, let's talk about the DFT logic location. By default, Fusion Compiler DFT places global test logic, such as the test mode decoders or the codecs, at the top level of the current design or current block. Other test logic types, such as lockup latches or reconfiguration multiplexers, they're inserted closer to the local point of use. To specify a different insertion location for the types of test logic, use the command setDFTLocation, give the hierarchy name, and the -include option to specify the test logic types. Note that the specified instance name has to be a hierarchical cell. It cannot be something like a library cell or black box or a CTL model. Also, this hierarchical cell must pre-exist prior to a specification. So in this example, if I want to place my DFT-Max codec logic inside a hierarchy called myCell, I would use the command setDFTLocation myCell-include codec. Once I specify that, the tool will place the remaining test logic into the top level. You also have a choice to place all DFT logic inside a particular hierarchy by just saying setDFTLocation myCell. Note that some DFT logic, such as pipeline scan enable registers or lockup latches, will be placed closest to the scan flops, irrespective of what you have specified with the setDFTLocation command. These are the types of test logic that are supported by the setDFTLocation command: the codecs as well as the wrappers. So for codec, it includes not just the compressor-decompressor, but pipeline scan data, as well as a test control module. For core wrappers, it would be wrapper cells, as well as the wrapper test modes. To summarize, we have discussed two commands that can be used to exclude scan cells from the scan chain and the difference in behavior. You can control cells that are put on a specific scan chain and the scan interface signals for that particular chain. We have discussed multiple test modes and how to configure the design for different scan architectures per test mode. We talked about partitioning design to define different scan architectures for each of the partition. We also talked about specifying a location to insert DFT logic.